The purpose of this video is to go over the Day 4 assignment on bond energy and activation energy. Question 2 was a heavily missed question. With this, you have to rank these bonds or intermolecular attractions in order by bond energy. The strongest bonds are going to be triple bonds, followed by double bonds, and then lastly, single bonds. What's represented with this final option is an intermolecular attraction. The dotted line is representing a hydrogen bond. We learned about hydrogen bonds in our previous unit. There is an attraction between the partially positive hydrogen of one molecule and the partially negative oxygen of another. These are much weaker attractions than the attractions with actual covalent bonds. Question number 3 involves identifying key information from a graph known as a reaction coordinate diagram, also called an activation energy curve. When you look at one of these diagrams, you will see a flat portion at the start. This is representing the amount of potential energy of the reactant molecules. Following this point, there will be a hill upward as energy is being absorbed. This absorption of energy is the energy required to break the bonds of the reactants. In order to separate bonded molecules, energy must be taken in. Following this, you will see a hill downward as the overall potential energy decreases. This is because energy is being given off as bonds are formed for the products. So notice we're absorbing energy as the reactant bonds break and releasing energy as the product bonds form. When we compare the amount of energy absorbed to the amount of energy released, there should be either a net gain in energy or a net loss in energy. What we're seeing here is there's a net loss of energy. The reactants have greater potential energy than the products. This is telling us this is an exothermic reaction, and it is therefore releasing energy. It's giving energy off, in this case 35 kilojoules. Because energy is being released, this reaction will overall feel hot. This relates to the next question because we are told that the reaction in the following question is an exothermic reaction. It would feel warm. Exothermic reactions would have to have a potential energy for the products lower than the reactants. The amount of energy absorbed is less than the amount of energy released. As a result, there is a net release of energy, an overall release of energy, which is why these reactions feel warm. Question number 5 was the most missed question on the assignment. This question involves evaluating 4 statements, only one of which is true for an endothermic reaction. Keep in mind an endothermic reaction has the reactants at a lower potential energy than the products. As a result, there is a net absorption or net gain of energy going from reactants to products. Only one of these 4 statements correctly describes this type of reaction. When I read the first statement, it says the energy absorbed from the surroundings during the formation of product bonds. And I'm just going to stop reading right now. This question has to be false because energy is not absorbed when bonds are formed. energy is released when bonds are formed. I am going to eliminate options 1 and 2 right away because they are talking about energy being absorbed when bonds form. That is incorrect. Energy is released when bonds are formed. Energy is absorbed when bonds break. So options 3 and 4 are the only ones that could be correct. Only one of these two options is actually correct for an endothermic reaction. When I read option number 3, the energy released to the surroundings during the formation of product bonds, so that is the downward hill. That's the energy released when products are being formed. It's saying that's more than the energy absorbed from reactants. So option 3 is saying the downhill portion of the graph is greater than the uphill portion. It's saying that more energy is released than is absorbed. This is true for exothermic reactions, but it is not true for endothermic reactions. In endothermic reactions, the energy released when product bonds formed is less than the energy absorbed when the reactant bonds break. This is the correct option because it's the only option that talks about energy absorption and release correctly while also making the correct comparison for an endothermic reaction. The next question involves evaluating this reaction coordinate diagram for an endothermic reaction. We know this diagram is showing an endothermic reaction because there is a net gain of energy going from the reactants to the products. We are asked what that total net gain of energy is. This gain of energy is represented by letter C. That is the difference between the reactant energy and the product energy. Because the products are at 300 units of energy and the reactants are at 100 units of energy, the difference is 200. The net gain of energy is 200, in this case kilojoules of energy. This is similar to the last question where we have to specify what the overall change in energy is for 3 different reactions. Reaction A is exothermic. There is a loss of energy when going from 30 kilojoules to 10 kilojoules. That is a decrease of 20, so I should select negative 20 kilojoules for the first reaction. The second reaction is also exothermic, and it goes from 40 kilojoules to 10 kilojoules. That is a decrease of 30, so I should select negative 30 kilojoules for that reaction. The last reaction is endothermic because there is a net gain of energy. This reaction is going from 65 kilojoules to 85 kilojoules. That is a net gain of 20 kilojoules of energy. Now that I've gone over the answers to this assignment, you should try the assignment again. If you are really following along with everything I was going over, you should be able to select the correct answers to each of these questions. Keep in mind that you are able to complete assignments multiple times. You should set a goal for yourself of getting a good score on every assignment, even if you have to try 2 or 3 times. If there is anything that you're not understanding, you should absolutely reach out to your instructor. We are here to help.